This demonstrates setting the IP boot parameters during a kernel load of the Linux kernel using qemu, which I always struggle to say, qemu. So just to give a little example of it booting, and then we'll break it down a little bit. The repo for this is the minimal Linux core utils. But we'll start with the example. So we have a kernel, which was just recently built, and we have an init.rd. That's the package that contains our init script, and it's our init script where we've put together all of the additional core utils and things like that that we want as part of our minimal distro. So this is just a minimal distribution, like you've heard of Alpine, Puppy Linux, etc., etc. This is just the tiniest you could possibly do. And these parameters, this append on line 8 is what gets passed to the Linux kernel, and then these get passed and set part of the IP utils, IP TCP stack setup. So if we run that, we will see. So let's just see how that runs, and then we'll go down a breakdown of how it's all put together. So because of the arguments and how we've set those up, we're getting the full kernel output. And if we do a quick search backwards, but before I do that, I'll just do the IPA, for example. We can see that we've got the internet address that we expect from the configuration of the kernel parameters, etc., 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 on Ether0. If we wanted to scroll back in time from the kernel boot, we can do that. I'm just using tmux here. If I can remember correctly, it's ip-config. You can scroll down. Oopsie. Let's do that again. ip-config. Press enter. There we go. So we can see there that, of course, as we expect, the kernel parameters are getting broken down into their constituent parts with the mask, etc., etc. So if we wanted to change that, we can of course do that by changing the kernel parameters. To get out of qemu, I'm going to do Control A and X, and that will terminate that instance. So just for example's sake, I'm going to set this to a class B net mask. Might not be called class B. I'm forgetting what they're called. Yeah, the class B. If you talk about classless address, classful addressing. Okay, so we've booted that new one, and if we go back to look at the logs for that IP boot, we can go IP config, and as we expect, we've changed the addressing as it's booted up. Cool. So let's go out of that, and if we had a look at that as well, just of the addressing, we can see that we've got the mask has changed as well, hence why our broadcast address has changed. I forget the subnet calculations off the top of my head, but it has changed, and the same we could do for that. But anyway, how's this put together? So as mentioned, this is based on this minimal Linux boot repo, which builds the Linux kernel. It also builds GNU core utils and the IP utils package. If I jump back into that, we can go through that little package a little bit. Just trying to remember what kernel, trying to remember what terminal I had that open on. Okay, so here we go. So basically, there's this build all script which builds all of the constituent parts needed. So it builds the Linux kernel, builds BusyBox. Alpine Linux is also built on BusyBox, or users built BusyBox, I should say. And we've also got OpenSSH built into that too. But the init script is particularly interesting because that's where you can have some customization. Note that we don't have to customize the init script. I just want to highlight that. The IP addressing comes as part of the kernel. that automatic addressing comes as part of the kernel. It's not part of the init script. But the init file, which is packaged into the init rd file package, is this. This is our own little init script that we've created. So that's the first thing that we'll ever run. So as you can see, we generate some SSH keys upon boot. What else should I show? That's enough for now. But yeah, I guess the last thing that the scripts do after building all of those different constituent parts is it assembles them into a rootfs CPIO, and that's what's passed to the init RD, and within that rootfs is this init file. So if you were to extract that rootfs file, for example, you'd find the init script, which I've got open down here. So in this scratch space, this is literally the extracted. Well, we create this and then we create the tar, the GZ out of it anyway. But this is what is the contents of the rootfs.cpio, and you can see our init file there. The script that actually creates the rootfs is this script here called build rootfs. So if we jump to build rootfs, it simply finds all of the files that we've compiled, and we have to arrange them in the correct way, of course. That's the OpenSSH, GNU utils, and IP utils, and it creates a CPIO archive to generate that package. So yeah, pause the video there and hopefully do a bit of a more clear write-up in the next day or two.